Okay, so in the last video, we discovered how sine, cosine, and tangent relate to the unit circle. So whenever I think about sine, I'm always thinking in my head that sine is the height, or it's the y-coordinate on the unit circle. And the cosine represents the horizontal distance, or cosine is the width on the unit circle, or it's the x-coordinate on the unit circle. And what tangent of theta is, what we discovered is tangent of theta is the same thing as sine over cosine. Or that tangent was the same thing as the slope of the line when we're rotating around the unit circle. So what we'd like to do today is let's try to evaluate any of the 6 trig functions using the unit circle. And I do want to make a comment that because it's an online class, you're allowed to use your calculator. I can't force you to not use it. However, if this was an in-class, this is a face-to-face class, my first exam, I usually don't let my students use a calculator to make sure they get this down. So what I'd just like to tell you is that when you're working on some, try not to use your calculator. I guess you could use your calculator, but try not to. It's really just going to help you in the future to have this stuff down without using your calculator. Okay, so let's get started. So let's say, for example, we want to know what the sine of 7 pi over 6 is. So this means I'm traveling a certain distance. I'm traveling 7 pi over 6 units around the unit circle. This is saying that t is 7 pi over 6. If you would like, t is really the same thing as theta. Now, oftentimes what the book does is when they're using radian measures, they usually use this t. When they are using degrees, they use theta. In this case, for our purposes, they're exactly the same. So don't let that confuse you. So how are we going to figure this out? We're going to go ahead and draw a picture. So let's go ahead and draw a picture. I always draw a picture. I've been doing math for a long time. I always just draw a picture. So here we have the unit circle. They have a length of 1. So 1, 0, and how about 0, 1? Okay, so I've rotated 7 pi over 6 units around the unit circle, so we're going to count. So use a different color, how about green? So let's count. 1, 2, 3, 4, 5, 6, 7. So here we are on the unit circle. We've traveled a distance t of 7 pi over 6 radians around the unit circle, or a distance of 7 pi over 6 units around the unit circle. Okay, so what we're going to do now is let's try to figure out the x and y coordinates at this location. If you'd like, you could use your t-bar here. Oftentimes, I was teaching you about this t-bar. The book often uses t-bar. So if you want to know what that reference number is, that's really what the last lecture was. But when I'm doing this, I'm just going to draw triangles. So let's think about this triangle that's created right here. Now this will be the same triangle as this one here in the first quadrant. So let's figure out what the x and y coordinates would be for this point on the unit circle, and we'll just use our hand. So if I put our hand up and I put down our reference number here would be what? Pi over 6. So if I put down my pi over 6 finger, the x coordinate will be root 3 over 2, and the y coordinate will be root 1 over 2. So if we write that up right here, this is a distance t, which is pi over 6. The coordinates here are going to be root 3 over 2 and 1/2. And again, notice if I kind of drew a line from here to here, we're about halfway up from 0 to 1. So the y coordinate is 1/2. Okay, so now since we're in the third quadrant, what happens is the x and y coordinates are just now going to be both negative. So here we'll have a negative root 3 over 2 and a negative 1/2. So if I want to know what sine of 7 pi over 6 is, what it's asking for is I just want to know what is the y coordinate for the terminal point. In this case, the y coordinate will be negative 1/2. So our answer to the problem is negative 1/2. Okay. Let's do another example. let's say I want to know what cosine of 5 pi over 3 is. So this means I've traveled around the unit circle a distance of 5 pi over 3. So here our t will be 5 pi over 3. Now I always just remember in my head that the unit circle is built off of increments of pi over 6 and pi over 4. So I'm going to use the best trick in the math book. I'm going to multiply cleverly by 1, hit this with a 2 over 2. So we have that our t is going to be the same thing as 10 pi over 6. So let's draw a picture. We're always going to draw a picture. Okay, let's see where we're at. So I need to count 10 increments of pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where we are on the unit circle. Okay, so we've traveled a distance t of 10 pi over 6. Let's draw a triangle. So here we have this triangle right here. And now by symmetry, if I'm thinking about really what this triangle would be in the first quadrant, it'd be the same as this triangle right here. It's just reflected over the x-axis. So if you would like, what our t-bar would be the distance from right here, or a reference number. A reference number looks like we would actually be moving 2 increments of pi over 6, so it would be pi over 3. So here would be pi over 3. So let's figure out the x and y coordinates for pi over 3. We'll put down our pi over 3 finger. The x coordinate will be root 1 over 2, or 1/2. And our y coordinate will be root 3 over 2. Or, if we look where we're at, if I kind of drop down, the x coordinate's about 1/2. Okay, so now I want cosine of 5 pi over 3. Remember, I'm looking at 5 pi over 3, which is the same thing as 10 pi over 6, 5 pi over 3. So the x and y coordinates here, well, for referencing here, the x coordinate is 1/2. Since the x is positive in the fourth quadrant, the y is negative in the fourth quadrant, root 3 over 2. So I want the cosine of that angle, so that means that I want the x coordinate, which will be 1/2. Beautiful. Let's do another example. What if we're not working with just sine and cosine? So how about we do tangent? Let's find tangent of 7 pi over 3. So if I'm trying to find a tangent of 7 pi over 3, I guess the first thing I'm going to do here is let's figure out where we are in the unit circle. So I need to travel a distance of 7 pi over 3 around the unit circle. Okay, well, notice that 7 pi over 3 is bigger than 2. 3 goes into 7 more than 2 times. So let's, I guess, figure out where we are. So I'm going to rewrite a 7 pi over 3. Let's see, 3 goes into 7. Let's see, 2 times. So 2 times 3 is 6. So how about we write this as 6 pi plus an extra pi. 7 pi is the same as 6 pi plus 1 pi over 3. So if I distribute the 3, this is 6 pi over 3 plus pi over 3. So this is 2 pi plus pi over 3. So what does this mean? This means I've traveled along the unit circle one whole time plus an extra pi over 3. So where are we on the unit circle? We've traveled one whole distance around, plus an extra pi over 3, which is 2 increments of pi over 6. So we are right here on the unit circle. So this is t, which is, this would be 7 pi over 3. Now this would be coterminal to just pi over 3. These are coterminal angles. So let's figure out what the x and y coordinates are right here. So for this location, and if we use our hand, if I put down my pi over 3 finger, the x coordinate is root 1 over 2, or 1/2. And the y coordinate will be root 3 over 2. Okay. So we're looking for tangent. Now tangent of theta, remember, is the same thing as sine divided by cosine. So tan of 7 pi over 3 is equal to the sine of 7 pi over 3 all over the cosine of 7 pi over 3. Okay, so let's figure out what that'll be. Okay, so remember, we're thinking here, this distance here from here to here is root 3 over 2. The distance from here to here is 1/2. So sine of 7 pi over 3, that's the y-coordinate. The y-coordinate was root 3 over 2. And we're going to divide that by 1/2. Okay. That's the same thing as the slope of that line. So remember, when we divide fractions, we flip and multiply. So this is the same thing as root 3 over 2 times 2 over 1. The 2's cancel. And I'm left with root 3. So what we have here is the tangent of 7 pi over 3 is root 3. Beautiful. Let's do another example. Okay, let's try and calculate, how about we do the secant? Let's calculate the secant of, how about 11 pi over 3. Okay. So our first job, I guess if I hadn't already said this, but if I forget to say that you should be pausing the video to try these. Anytime I introduce a new example, you should be pausing the video, trying it on your own before we go to the next example, or before I show you the answer. So what are we going to do first? We're going to figure out where we are on the unit circle. So notice here that this is bigger than 2 pi. 3 goes into 11 more than 2 times. So what I'm going to do here is I'm going to write this 11 pi over 3. Let's see, 3 goes into 11, what, 3 times? 3 times 3 is 9, so this is the same thing as 9 pi plus, let's see, what, 9 pi plus, what do I need, an extra 2? Plus 2 pi all over 3. Or this will be 9 pi over 3 plus 2 pi over 3. This is the same thing as what? 3 pi plus a 2 pi over 3. Or you could think of this as I've traveled around the circle 1 whole time plus an extra half plus, instead of 2 pi over 3, if we want to move in increments of pi over 6, how about we write that as multiply by 2 over 2, 4 pi over 6. So let's figure out where we are on the unit circle. Let's draw the picture. So where are we? Well, I've traveled 1 whole time around the unit circle, then I've traveled an extra half, and now I need to move 4 increments of pi over 6. So from here, we'll move 1, 2, 3, 4 increments of pi over 6. This is where we are on the unit circle. Okay. So what I'm going to do here is I'll draw that same triangle up in the first quadrant, and we'll try to figure out what our x and y coordinates are here. So in this case here, I hope you see that the reference number, or what we call t-bar, will be pi over 3. So this is t equal to pi over 3, or you can write t-bar if you'd like. The x and y coordinates here will be root 1 over 2 and root 3 over 2. So 1/2 and root 3 over 2. But if I'm down here, the x coordinate will be 1/2, and the y coordinate will now be negative. So I want to know what secant of 11 pi over 3 would be here. Okay, so secant of 11 pi over 3, well, I don't usually like working with secant. I like to think about secant always in terms of sine and cosine. So remember that secant is the reciprocal of cosine, so this would be 1 over the cosine of 11 pi over 3. Okay, so cosine of 11 pi over 3, that's where we are here. So the cosine is the x coordinate, so I'll grab a 1/2. So this will be 1 all over 1/2. How many times does a half go into whole? 2 times. So the answer is 2. So we have that the secant of 11 pi over 3 is equal to 2. And that is our answer. Okay, let's do one more. What if we have a negative angle? Let's calculate the tangent of negative 7 pi over 6. So the negative just means that we're traveling around the unit circle clockwise rather than counterclockwise. So what are we going to do? We're going to draw a picture. Okay, so where are we? So now I'm no longer moving this way around the unit circle. I'm moving clockwise now. And I need to move 7 increments of pi over 6. So here's 1, here's 2, here's 3, here's 4, here's 5, here's 6, here's 7. This is where we are on the unit circle. So let's draw a little triangle here. Now this would be the same triangle in the first quadrant right here. So if we want to know what our reference number here would be, our reference number would be the distance from here, that'd be pi over 6. So let's figure out what sine and cosine of pi over 6 is. Putting down this finger, looks like the x-coordinate would be root 3 over 2. The y-coordinate would be 1/2. Again, if I move over this way, I'm about halfway up on the unit circle. Okay, but I want to know the coordinates here. So maybe I should draw this. So in the second quadrant, the x-coordinate is negative, the y-coordinate is positive, the x-coordinate is negative, so negative root 3 over 2, and the y-coordinate is 1/2. Okay, so if I want to know what tangent is, I want to know what the slope of this line is. So without anything, without calculating it, just thinking about it, notice here that this line has a negative slope, so I should expect my answer to be negative for tangent. Okay, to figure this out, remember that tangent is the same thing we have right here. Tangent is the same thing as sine of negative 7 pi over 6 all over the cosine of negative 7 pi over 6. Okay, so sine of negative 7 pi over 6, that's the y-coordinate, that's 1/2. The x-coordinate is negative root 3 over 2 divided by negative root 3 over 2. So remember, when we divide fractions, we flip and multiply. So this is 1/2 times a negative 2 over root 3. Let's notice that these 2's will cancel out, and I'll be left with a negative 1 over root 3. I'm oftentimes fine with answers like this, but if you're checking your answer in the back of the book, they're always going to want you to rationalize the denominator. So I'm going to multiply this by root 3 over root 3. Best trick in the math book. What are we going to get? We're going to get a negative root 3 over 3, which is the answer. Tangent of negative 7 pi over 6 is negative root 3 over 3, and that's the answer. Hope you enjoyed this lecture. We'll see you in the next one. Take care.